All right, trust you did well on quiz 29 in your last lesson. I did end up making that last problem a bonus question. So if you're grading it, I made that a bonus. We hadn't seen anything like that last problem, number 17, before seeing it on the quiz. And I didn't feel that was fair to the students to have to see that for the first time. So anyway, that was made bonus. Let's have our desk clear of everything except for a pencil and our speed drill booklets. Pencil and speed drill booklets. And we've got a pretty basic speed drill on here, not much going on. There's one problem that involves positive, negative numbers. Everything else is just some basic add, subtract, multiply, divide. You're going to have 4 minutes for speed test 44. So speed drill 44 there on page 21. You'll have 4 minutes for this speed drill, and you may begin. So another minute to work it. Stop. All right, now put your pencils off your desks and get pens out. Pencils off your desks. Pens out and exchange with the person behind you, person in the back. Bring yours to the front. All right, say your name and pen as the grader next to where it says speed test 45. There at the bottom of speed drill 44. And let's see how we did. Number one, we're not having to find the mean of these four numbers at least, but we did have to find their sum. 25,912. 25,912. For number two, we needed to multiply to get 53,592. 53,592. Number three, subtracting to get 20,853. 20,853. For number four, we don't need to subtract. We need to add the inverse. Make that a plus positive 6. But do we ever when we subtract, when we add the inverse, we got a negative 12 and a positive 6. Since the signs are different, class, we subtract and choose the sign of the greater absolute value. Negative 6 should be our answer. Negative 6 when we add the inverse. Number 5, we subtract. We get 12,971. 12,971. Number 6, 3 decimal places in our answer. 5.184. 5.184. Number 7, we need to throw a whole bunch of zeros in there, do a whole bunch of borrowing, and get 0.2237. 0.2237. Number 8, finding the sum of those three numbers gives us 152,544. 152,544. The last two are probably the longest ones. Number 9, we multiply, get 172,870. 172,870. And number 10 didn't divide out evenly. They wanted us to round to the nearest tenth. It rounds to 1.6. It rounds to 1.6. All right, these are 10 points each. Figure the score, put it in the score blank. Also put the score next to where it says speed drill 44 on the score page. Question.
So what was number 1?
Number 1 was 25,912. Corey?
Well, what if they didn't put a decimal on number 6?
The decimal is actually one of the biggest things on number 6. It would be all wrong. Yeah. So I want to see that they knew the 3 decimal places. All right, 10 points each. Figure the score. Put it next to where it says speed drill 44 on the score page. Once you got the score on there, in both places, return to the owner. And this was a tough one. Were there any hundreds today? This was a tough one. Okay, no hundreds. 90s, just missed 1. Okay, good, Corey. 80s, just missed a couple. Okay, several people in that boat. All right, 70s, still passed. Did well, okay. All right, go and pass those forward if you would, please. And we have a test coming up. We have a test coming up tomorrow over Chapter 7. We've been going over things for a while now. I feel like we got a pretty good handle on some things. But let's just make sure we're good to go. Open up your books. Open to page 292. We did part of the review yesterday, setting up the quiz. Went over the quiz just a few moments ago before we started the video. And so that was some good review for us as well. Want to finish up our review here. What are we talking about? Counting principle, right? What do we need to do with the fundamental counting principle, class? Multiply. Multiply possibilities together. Every time there's a choice to be made or there's a set of possible outcomes, we figure out how many in that instance, multiply that by the number of outcomes in the next instance, and so forth. We talked about the likelihood something's going to happen, class. Probability. Each possibility is called an outcome. The choice of the select group of probabilities is called an event. What if we got multiple events that could take place, either this or this and this, class? Compound event. Very good. What do we do if the compound event uses the word or? Add the probabilities. What if the event has an and in it, class? Multiply them together. We talked about, let's see, after probability, we talked about statistics, said that a group of facts or information in general is just called data or data. Statistics specifically is that branch of mathematics that studies data, the collection of data, so forth. We said if you ask a question to a whole bunch of people, that's called a survey. The group of people you actually asked the question to and give you an answer is called the sample. But the group you're trying to represent is called the population. So if we surveyed all of your parents, that's not a very random sample, is it? But if we surveyed all of your parents what they thought we should do here in Columbus, and we said, this is what the citizens of Columbus think, what's the population? Citizens of Columbus. What's the sample? The parents I interviewed. But if I said, I'm going to ask all your parents a question, what do Americans think? Well, now the population is all of America, and the sample is still just your parents. Not a very well-constructed survey in that instance. We said if we'd made a table listing all of the total of all your parents' responses of stuff, just their responses, class, that's called a frequency table. If we used those responses and divided each group of responses, the total for each response, by the total number of people surveyed, that would give us the probability of a particular response. That's called a relative frequency table. We talked about 3 different indicators of what's normal in a set of data. They're actually called measures of center. 3 measures of center. They all begin with the letter M, class. Mean, median, mode. The mean is the average. The median is the middle value. Only the middle value, though, once you've done what? Ranked the data. You got to rank the data first. And then the mode is the number that occurs most often. Now, I say number that occurs most often. You can't find an average unless it's a number. You can't rank unless they're numbers and then find a middle. Do they have to be numbers to find the mode? No. Because remember, the mode can apply to what's called categorical data also, can't it? And then we said if we wanted to find the difference between the biggest and smallest number in a set, that's called the range. That just kind of tells us how spread out the data is, gives us an indicator there. Let's see, we said next we talked about the difference between 2 different types of probability. One type of probability looks at what has already happened. We look at, for instance, for the past 100 years, on April the 11th, has it rained? For the last 100 years, how many times has it rained on April 11th? How many times has it not rained on April 11th? And so the next year we say the likelihood of it raining on April 11th is 58%, because 58% of the time over the last 100 years it's rained on April 11th, including today. All right? Well, that's what type of probability?
Theoretical or experimental?
Experimental probability, because it's based on what has actually taken place. We actually have observed data. But if I just said, coming up in about 5 days, April the 16th, what's the likelihood it's going to rain? We say, well, either it will rain or it won't rain. That's a 50% chance that it rains. Well, okay, that's just theoretical probability, isn't it? So we got those 2 different types of probability that we need to be familiar with. A lot of terms that I just gave you. Make sure you know those terms. Oh, one last thing I needed to mention real quick with the mean, median, mode. Mode just is what occurs most often. Is there always a mode? No. But if there's numbers, there can always be a mean and there can always be a median, right? One of them is usually better than the other depending on the set of numbers. What are we looking at? If we're trying to determine what's the best indicator of normal, what's the best measure of center, we need to look at the data set and see if there are any outliers. What's an outlier, class? A number that's either really big or really small compared to all the other numbers in the set. It's really far away. It lies way outside where the other numbers are. They're all clustered together, and then there's that one. Okay, that's an outlier. If there are outliers, what's better, the median or the median? The median, because what does the median do to the outliers? Just salt and peppers them right off anyway, right? So the median is what we call resistant outliers. It's not really affected by it. But the mean, very affected by outliers. Well, what if there aren't any outliers? What if all the numbers are nice and close together? Well, then the best measure of center is the mean. The actual average is usually best unless there's those outliers present. Page 292. That's a quick review over that stuff. Let's review some other things. Now, number 14, read that for us if you would, Luciana.
The vehicle will be a car or a truck and will be red, black, or white.
All right, so she is hell-bent on either a car or a truck. She does not want an SUV. She definitely don't want a minivan. And she specifically wants red, black, or white. Because if she's going to Pensacola Christian Academy, where I went to school, and where they print these books, those are the school colors. So of course you want red, black, or white. Here, of course, we would want blue, gold, or white. But anyway, how many different ways can Helen... Now, this doesn't get into vehicle brand, by the way. So just looking at car, truck, red, black, white, how many possible outcomes, class? 6. 2 types of vehicle, 3 colors of vehicle, multiply 6. How many had 6? I heard someone else say 5. Come on now. Number 15. Read number 15 for us, Michael.
Each of the Robinsons' 3 children, Cameron, Dale, and Paige, were allowed to choose 1 drink and 1 snack. The drinks were either water, soda, or juice. The snacks were either a candy bar, a granola bar, or a bag of nuts.
How many different ways could the snacks be put together? Take a moment, think it through, write your answer down. And what do you think, Michael?
27.
27, right, because they're going to choose either, for their drink, they're all going to choose either water, soda, juice, that's 3 options. And then they're each going to choose 1 of 3 different snacks, but there's also 3 different kids making these choices. So each kid gets to make those choices, so we end up with 27 different ways snacks could be compiled. Questions on that? All right, let's drop down to number 16 through 20. 2 bags, that's important, contain marbles. First bag, 3 red, 2 green, 5 blue. Second bag, 3 red, 4 green, 3 blue. So there's how many total marbles, class? 20, but they're in 2 separate bags. So as you think through this, remember each bag only has 10 marbles. At your seats, do number 16. We don't need to fill in all the extra blanks. I just want you to find the probability, though by now we should know P green is how we would write the probability. Or you can even do P green 1 for probability of green from first bag, since number 17 wants P green 2, probability of green from second bag. What is number 16? The probability of a green marble from the first bag. Ben?
1/5.
1 to 5. Very good. 2 green out of 10 total. 1 to 5. How many had the same answer? Now number 17, the probability of green from the second bag. Take a moment. Probability of green from the second bag. And what do we get for that one? Joel? 2 to 5, because there's 4 green out of 10 in the second bag. So 2 to 5 is what it reduces to. How many had the same answer on 17? This is going to be easy. We're going to be able to do this tomorrow. All right, number 18. Now it gets complicated. Drawing a red or blue marble from the first bag. P red or blue 1. Red or blue from the first bag. And Corey, what you got?
4 to 5.
4 to 5. Red or blue, class or tells us to add. So we got from the first bag 3 to 10 red. We got 5 to 10 blue. That's 8 to 10, which reduces to 4 to 5. Great job. Number 19. Drawing a red from the first bag and then a blue from the first bag after we put that first marble back. Drawing a red and then a blue from the first bag, assuming replacement. Doing number 19. Number 19. Should we reduce the answer down? Try to cancel as needed here, because when it says and, class, we multiply. When you multiply, remember to cancel. So, Bryson, what 2 things are we multiplying here?
3 tenths and 2 tenths.
3 to 10 times 2 to 10?
Oh, 5 to 10.
5 to 10. 3 to 10 times 5 to 10. But we've got to cancel stuff. What can we cancel here, Bryson?
5 and 10.
To get
1 and 2.
1 and 2. So what's our answer?
What is it? 320.
3 to 20. How many had 3 to 20? Okay, we got some questions here. Ben, Michael, questions? Figured out now?
I just put the wrong number.
Be careful. Number 20. Drawing a green from the first bag, then drawing a green from the second bag. P green 1 and green 2. P green 1 and green 2. And since they're from 2 different bags, we don't need to replace, because the first draw in no way affects the second one. They are mutually, they are independent events here. Jalen, what did you, well, first of all, it says and, so we had to multiply. What was pea green 1?
1 to 5.
2 to 10 or 1 to 5. And what's pea green 2?
2 to 10.
4 to 10 or
4 to 10 or 2 to 5.
2 to 5. And so we multiply, we get, careful, 2 to 25. Should have been 2 to 25, right? Green in the first was 2 to 10, green in the second 4 to 10. Do that reducing down. How many had 2 to 25 for the probability of drawing green from each bag? Questions? Questions on those? Look across the page. Some interesting questions here. Number 21, read that for us, Kirsten.
A survey is taken to determine the most commonly owned breed of dog.
All right, so the question is, who should we survey if we want to find out the most commonly owned breed of dog? Should we ask A, a group of kindergartners, B, people at a dog park, C, people purchasing dog food, or D, attendees of a dog show? Now, one of them is obviously wrong, class. Kindergartners. But you see the other 3 really sound pretty good. What would be the best one to choose? What do you think, Kirsten?
B.
But you're only getting those people at that one dog park, right? So I would say probably not B, though I don't think it's a worst thing in the world, but you're only getting that group of dog park people. Dog park people tend to have a little bit bigger dogs. They want to give them a chance to run and play. So that's going to skew our results just a little bit. Something that would apply universally. What do you think, Ben?
D.
But the attendees of a dog show oftentimes have unique breeds, rather rare breeds. So that's going to be a hard one to get a good feel for the most common breed. So class, that leaves, because what do all dogs have in common? Not all dogs go to dog parks, not all dogs go to dog shows, but all dogs have to eat dog food. So C is the best one, but that was a hard one. That was a really tough one. Let's take a look at 22, see if we can think through this one. Read number 22 for us now, if you would, Luciana.
A survey is taken to determine the most frequently used hiking trails in the area.
All right, so what are the most frequently used hiking trails? Should we talk to farmers, forest rangers, families with small children, or families on a cruise? Again, I think some of these are kind of obviously wrong. Joel, which ones do you think are obviously wrong? Farmers. Not that farmers don't take walks, but that's not their thing necessarily. They get their exercise plenty in other ways. And then also, another one's glaringly wrong.
Families on a cruise.
I think families on a cruise is also glaringly wrong, right? They're on a cruise, they're not hiking. Now, families with small children, do they go hiking? They might, but I would say it's less likely. So the obvious one here, a lot more so than 21, how many already had B? Yeah, I think B is a little bit more obvious there. Let's go to number 23. Surveys taken to determine the most popular fitness application for mobile devices. Okay, so what app do you want on your phone to help you track your fitness? A, children on a youth t-ball team. B, emails sent to app programmers. Senior citizens in an aerobics class, or runners on a local jogging loop. I think this one's a little bit tricky. What are you thinking here, Michael?
D.
I'm thinking D as well. The only argument I would have is you're only interviewing the people at that one jogging loop, but you could get a whole lot of people if you go there multiple days in a row. You could get a good group of people. I think you want to go to multiple locations to get a more diverse group, but I think that's probably the best answer there. How many were also thinking D? Thinking D. Again, the people who are using the app would be the most likely to be the ones to be asked. So of the 4 answers, that's the best one. It's not the best way to do it, but it's the best of the answers they gave. And number 24, surveys taken to determine how often senior citizens replace their cell phones. I'm not one to judge here, and I'm not even a senior citizen. A, an email survey sent to people over the age of 65. B, customers leaving a cell phone store in the mall. C, occupants of a retirement community. And D, students at a local college. What do you think is the best group to ask? Hey, how often do elderly people replace their cell phones? Ben, what are you thinking?
A.
Only problem is how many people over 65 are checking their email? No, I wouldn't say none, but there's probably a lot fewer, so you're not going to get as many responses. So that's not a bad one, though. At least you're targeting the right audience. So that's not of the, I would say of the, like there's one obvious wrong answer, that's D, okay? But I would say A, B, and C all sound okay, but there is a better one. What do you think, Jalen?
C.
Well, but most of the people leaving the mall cell phone store are probably not old, right? Most old people tend to avoid the mall in general. Oh, you said C. I'm so sorry. I am so sorry. Yes, C. The Occupants of a Retirement Community. Go where the old people are and ask them, hey, have you changed out your cell phone recently? When was the last time you updated your phone? Got to do. I'm so sorry, Jalen. Yes, you are correct. C. I don't know. My brain was just hearing B right there. Good. All right, questions on those? Number 25. We're going to make a frequency table. Get out a sheet of paper. Let's get out a sheet of paper. Let's make a frequency table here for number 25. And read. Number 25. Once you've got that paper out, you're ready to go. Corey, nice and loud so the camera can hear you.
A hardware store manager needed all the rows of wallpaper in the store's inventory before ordering more wallpaper. The inventory had the following rows of wallpaper: 10 in color, 25 textured, and 15 natural material.
All right. So we need a title for our frequency table. What's a good title here? What are you thinking here, Elaine? Not cheeseburger.
Rolls of wallpaper.
Rolls of wallpaper. All right, so there's our title. And how many rows do we need in our frequency table here? Kirsten?
3.
3. And then at the very bottom, we do need a 4th row that says
Total.
So we're going to have 1, 2, 3, 4. And we just need 2 columns. The bottom, of course, is going to say total. What should those 3 labels be in the frequency table here, Bryson?
Or color.
Plain color.
Texture.
And
Natural material.
natural. I ran out of room for material. We'll just say natural. Or all natural. I don't know.
Natural M.
Natural M. Okay. Natural material. All right. And the numbers, don't require a whole lot of, brains here. So let's go to Luciana. What should we write in for our numbers? Next to plain color, put. She's a straight A student. I don't take that personally. People on YouTube he's so mean. Texture. 25 and natural? 15 for those eco-friendly people. And we do need to do a little bit of math to get the total, but it shouldn't be too hard of math here. What is our total, Joel? 50. And that's a beautiful number. I love 50. It's such a nice number because we're now going to make a relative frequency table. And in a relative frequency table, we need to figure out relative frequency. Class, relative frequency is another name for probability, but not randomized probability based on actual results, the experimental probability. And one way to show probability is in terms of a percent. Percent means hundredths, and 50 can turn into hundreds really easily. So I like that number 50. So now, rolls of wallpaper. Plain, that's an I, it just doesn't look like an I. Plain color, it's going to be something. Hush pen, textured. And I'll write smaller this time. Natural materials. Total. I already know what's going to go with the total spot, so let's just write it down now, shall we?
100.
100%. Or you could just write 1. Because that's always the total in a relative frequency table. By the way, that's one dead giveaway, and I can tell the difference. Is it frequency or relative frequency? Well, if it's got anything other than 1 or 100%, it ain't relative frequency. All right, so I think the easiest one here to me is textured. Because, class, what fraction is textured? Half. And so what percent is that? 50%. 4.5 if you just really don't want to put. Anyway. Plain color. That's not too bad, because if I make a fraction, 10 over 50, that reduces to 1/5, which is what decimal? 0.2, which you could put that, or if we're putting percents, we could put 20%. And I usually cheat on the last one. Now, I will say this. If I made a careless bonehead error, and I messed up one of these two numbers, I could risk on the test tomorrow missing another answer. couldn't I? So maybe on a test, it's best not to be lazy, just to be on the safe side. And so we shouldn't say what's 100% minus 70%. Well, class, that would be 30%. So that's the lazy way to do it. Maybe the better way to do it would be to go ahead, make one more fraction, class. 15 50ths. And you could multiply top and bottom by 2 to get 30 hundredths. And then get the 30%, and then use that check. Do they really add up to 100%? Okay, they do. Now I'm really confident my answer is right. I will say my laziness usually wins out. But on a test, I might take the time to go ahead and work out all of them just to make sure I'm on the safe side. We all feel good about making a frequency table versus making a relative frequency table. No. Feels pretty good? No, not okay. Look at number 26. And read numero 26 for us, if you would, nice and loud. Jalen.
High school students were asked, what is your favorite meal of the day? The results are as follows: 65 breakfast, 100 lunch, 120 dinner, and 20 undecided.
All right, at your seats, come up with your own title this time. Everybody can come up with their own title that makes logical sense. I'll let Jalen pick the title that goes on the board, though.
Favorite meal of the day?
Favorite, I'm just going to say favorite meal, though we should specify this favorite meal is applying to what group of people? High school's kids, or we could even say teenagers. Favorite meal, teenagers. Because again, it might be different for different age groups, but for teenagers that we surveyed, our sample is intended to represent teenagers. So there we go. And the first row of the table should say what? Ben?
Breakfast.
Breakfast. Let's start at the beginning. It's a nice logical order. Then the next thing to stay in the nice logical order should be, Kirsten? Lunch. And then after lunch, the next logical one would be what, Corey? Dinner. How many call it dinner at your house? How many call it supper at your house? Nobody calls it supper?
I call it both.
Okay. All right, and then the last one is kind of unusual because there are some people who are just, they can't make up their minds. And so, class, our next row should say undecided. But the final row always says total. You have lines on your paper. I don't, so I'm going to make some lines. Go ahead and fill in all the values, including the bottom, for your frequency table. I'm going to fill in all the columns here on your frequency table. Help your brain think better if it's not being resting on you. And what is that total, Bryson?
115 or 215. Fine. Oh, 315.
I'm getting 305.
Yeah.
And let's get 305. Okay, so if you didn't have 305, go and write that down now. That is a really obnoxious number, I'm not going to lie. I don't like 305 one little bit. Although, I think we're going to find the division isn't too bad. Should have 305 for that. Now let's make our relative frequency table. Favorite meal, teenagers. Sounds like a monster is talking. Anyway. All right. Break fast. Lunch. Some people break fast for lunch. Anyway, dinner. Oh hush. Undecided. And total. at least we can do what every time we make our fractions? We're going to be able to reduce at least by 5 every time. So when we make our first ratio, we'll let Joel decide the first one we're going to find.
We could do breakfast first.
Breakfast first sounds good to me. So we make our initial fraction, Joel.
So our initial fraction is 65 over 305.
I mean, I could just divide straight up, right? And honestly, maybe it'd be faster just to do that than to divide the 5 out of top and bottom. We get smaller numbers if we do the other. Maybe we should just divide. Put the 65, this 305 is going to be an easy thing to divide by, I think. Right? We can all see that 3 goes into 6 class twice. Is this 5 really going to mess stuff up? Not too bad. So 1, 2, 3 digits, 1, 2, 3 digits. There's our 2. 2 times 5. Carry the 1. 2 times nothing plus 1. 2 times nothing plus 1. 1. 2 times 3. 6. And we subtract to get 40. Bring down the 0. How many times 3 go into 4? Once. And of course that's going to be a 305. We subtract to get what, anybody? 95. Bring down a 0. How many times 3 go into 9? Only 3 times. Now if we're cutting it off here, what does that round to, class? 0.21 or 21%. I'm going to go and do 21%. That wasn't really that bad. I mean, 305 is not a terrible thing to divide by. At your seats, find lunch. Let's just go in order. Next, find lunch. Once you've got it, check your answer. If you're good, move on to dinner. And for sake of time, we'll stop there. As long as you make sure at the bottom it adds up to, class, 100%. Should add up to 100%. The last undecided is 7%. As long as you got it adding up nicely to 100%, you're going to be good. Drop down to number 30. Drop down to number 30. I want you to rank the data on number 30.
Yeah.
We did 27, 28, 29.
I thought we'd skipped one of those.
We skipped 30, but 30 is. Yeah.
Oh, 30's.
Oh, I
They did already rank 30. Okay.
Actually,
accidentally did 30, I forgot.
Okay, I was about to say, we did not do 30 yesterday as a class. So if you've already done it, you can sit there. The rest of you doing 30, you've already ranked it, so find for me the median, mode, and range. The median, mode, and range. Should take about 15 seconds to get those three. Median, mode, range. Median means? Middle. What's the middle? 16. Mode means? Most often. That would be? 14. And then the range, we just subtract big minus small class? 16. That's easy. Now, the harder number is the mean. Mean means? Average, which means we have to add them all together and divide. In this case, class, by 7. At your seats. Add and divide by 7. We add them all up, and we get what when we add them, Joel?
19. Oh wait, no wait. 133.
133, and then we divide by 7, and we do get what for our mean, Joel? 19 as our answer. How many had 133 as the sum? 19 as the mean? Questions on all this stuff? All right, we're going to be able to be good with this for the test tomorrow. Test 7. Test 10. We're using Abeka Test 7 if you're watching on YouTube. We're using Abeka's Test 7 because remember we did a couple of chapters there of extra stuff from the financial literacy supplement. So in Abeka it's Test 7. For you guys it's Test 10. Next lesson over Chapter 7. So there we go. When the bell rings, you are dismissed. Have a wonderful rest of your day and do well on the test tomorrow.